one of the cool things about a power series is that it will actually allow us to represent other functions as power series. We know, as an example, that the sum n equals 0 to infinity of x at n is a geometric series, specifically for the absolute value of x less than 1. So the sum is going to be 1 over 1 minus x. Now think about this. We think of a geometric series. There's a couple different forms, but for this form, AR to the n, in this case, x happens to be equal to r. Because what we've seen before is the idea that this will sum to a over 1 minus r. So a is some constant, and r is that radius that I'm working with. So I know that this to be true. So this particular power series sums up to 1 over 1 minus x for absolute value of x less than 1. So how can I take this and modify it to represent this function instead? Well, what if I write this as 1 over 1 minus a negative x? That's 1 plus x, right, in the denominator? Well, that will be equal to this sum, n equals 0 to infinity. Remember, I need the absolute value of x to be less than 1. So that means I can put a negative x in there. This would be a negative x raised to the n. That's all I did. I substituted negative x in for x, which of course I could rewrite as the sum n equals 0 to infinity of negative 1 to the n times x to the n. And we should also, once again, check the endpoints. Now I know this was going to converge for absolute value of x less than 1, which means my radius is in fact 1. And I know my interval will be negative 1 to 1. But again, checking the endpoints to determine whether or not it will converge with negative 1 or if it converges at the other end at 1. Which I'm not going to do here, but it's something you should do. Does this negative 1 to the n, does that change anything or not? That's something you really should take a look at. Okay, now what happens if I let x equals x squared? Well, I know that 1 over 1 plus x is equal to the sum n equals 0 to infinity of negative 1 times x to the n. So if I let x equal x squared, that would then imply that 1 over 1 plus x squared must be equal to the sum n equals 0 to infinity, negative 1 to the n times x squared to the n, which I would rewrite as the sum n equals 0 to infinity, negative 1 to the n, x to the 2n. So, where will that converge? Well, again, I know that I need the absolute value of x squared to be less than 1, which again tells me I have both an interval and radius of 1. So I'm going to end up with the exact same interval and radius there. You can do the algebra and actually confirm it. Now, so far, we've looked at the idea of all of these have been centered at a equals 0. Remember, we said the general form for the power series was the sum n equals 0 to infinity of some constant cn times x minus a to the n. Well, so far this constant c has been 1, and a has been 0. We centered it at 0. So let's take a look at this function, and I want to use the geometric series of that basic power series, and I want to center it at a equals negative 2 instead. So I want to write this as a geometric series, and I need it in this form. If I can get it in that form, then I know what it's going to be. So what I really need is I need the form on the denominator of some constant minus x minus a negative 2. Now, why? Well, remember we said I want it centered at a equals negative 2. And I need x minus a. That's how I'm going to center it at a. But a is a negative 2, so this is really x minus a negative 2. So that's what I need right there. And then I'm going to have some other constants so I can put it into this form. Well, that means really all I have to do is take k minus x minus a negative 2 and set it equal to 4 minus x. So I need to get it into this form. So when I do, what do I get? I'll get k minus x minus 2, I have a triple negative, equals 4 minus x. Well, the x's cancel. So that implies that k equals 6. Well, if k equals 6, then what I have is 3 over 6 minus x plus 2. And obviously I need to keep those parens in there. The x plus 2, that's the x minus, minus 2, or negative 2. I need to keep the parens. I don't want to simplify and combine like terms. I don't want to take that 6 and subtract 2 from it, because then that puts me right back to where I started from, and I haven't gained any ground. But I still need it in this form. So what I do is I'll factor out a 6. When I do that, I'm going to pull it to 3. I have a 3 over 6 times 1 over 1 minus x plus 2 over 6. Now, this is what I'm thinking of as my r. So that tells me that 3 over 4 minus x is equal to the sum, n equals 0 to infinity, of, let me see, I started off with, okay, that, so that I'm just going to have an x, well, this is plus 2, it looks like a 12 there, that's plus 2, x plus 2 over 6 raised to the n, but I need this constant, so I'm just going to put this constant of 1/2 out front. I could have easily put it inside the summation, it doesn't really matter, it's a constant. Okay, so that's the series. I can represent 3 over 4 minus x as 1/2 times the sum n equals 0 to infinity of x plus 2 over 6 all raised to the n. But I still need to know, where is this going to converge? Well, what I'm going to need is the absolute value of x plus 2 over 6 that has to be less than 1. I know that to be true. Well, that would then imply that the absolute value of x plus 2 has to be less than 6. Well, right away now I know my radius of convergence will be 6. So now I need to figure out what the interval is. So that's going to imply that a negative 6 is less than x plus 2, which is less than 6. That's going to imply, if I subtract 2, that negative 8 is less than x, which is less than 4. So I know it's going to converge on negative 8 to 4. So there's my interval. But again, I should consider what's going to happen at the endpoints. I'm not going to do it here. It's a good exercise for you to play with. Substitute in negative 8 and 4 for x, see what you get, and make a determination whether or not that's going to converge. Now, find the power series for f of x equals 3 over 2x minus 1, centered at a equals 0. So I'm back to centering at 0. Well, I know if I can get this in the form of some constant, I'm going to use c this time, over 1 minus r, that's going to equal the sum, n equals 0 to infinity, of c times r to the n. So can I get it in that form? Well, if I take a look here at, let's see, 3 over 2x minus 1, if I factor out a negative 1 from the denominator, I can get a negative 3 times 1 minus 2x. Well, when I look at it that way, I'm going to erase that negative and put it up here. This will suggest that c equals a negative 3 and r equals 2x. So this is telling me that 3 divided by 2x minus 1 is actually equal to a negative 3 times the sum, n equals 0 to infinity, of 2x to the n. Again, this negative 3, you can put it back in to kind of match this format, or you can pull it out. It doesn't have an n involved in it, it's just a constant, so I can leave it inside the sum or pull it outside the sum, it won't make a difference. But once again, I need to think in terms of the interval and ratio of convergence, interval and radius of convergence. So I know the absolute value of 2x has to be less than 1. Well, that would then imply the absolute value of x has to be less than a half. So that says that my radius is actually going to be a half. And for my interval, I need to solve, well actually it's already solved, negative 1/2 has to be less than x, which has to be less than a half. That tells me that my interval is going to be negative 1/2 to 1/2. Now again, we should check endpoints. I'm not going to do that here, but if you do check it, you will discover that it will diverge at both of those endpoints. But either way, you should check it to convince yourself that that's going to